Welcome to the deep dive. Today, we're diving into a really crucial health topic, something that affects millions globally, gastric cancer.
That's right.
And, our source material immediately points out this fascinating paradox. While overall gastric cancer incidence is actually going down worldwide.
Which is good news generally.
Exactly. But there's this specific type, cardiac-gastric cancer, that's sort of quietly on the rise. It really makes you wonder, doesn't it? What's driving that difference?
Absolutely.
So our mission today is to really unpack this complex landscape of risk factors. We want to distinguish between those two main types, cardia and non-cardia, and understand how these factors are evolving.
Yeah.
You've given us some fantastic source material, lots of detailed tables and figures, and we're going to break those down for you, pull out the key insights.
And understanding these nuances, it isn't just academic. It's absolutely key for effective prevention. We'll be looking at the solid scientific evidence that helps connect these dots.
Giving you the clearest picture possible.
Exactly. Why these trends are happening and why they're so distinct.
Okay, so let's start big picture. Even with that overall decreasing trend, gastric cancer is still the 5th most common cancer worldwide.
Still very high up the list.
And tragically, it's the 3rd most common cause of cancer-related deaths. Just think, in 2020 alone, over 1 million people were diagnosed.
1 million people. That's a staggering number. Really puts the global impact into perspective.
It does.
And to give some context for those numbers, our source mentions the lifetime risk by age 74. It's about 1.9% for males and just under 0.8% for females.
Okay.
But what's particularly striking is the huge regional difference. Like in East Asia, the rate is way higher, 32.5 per 100,000 for males.
Wow, compared to
North America, where it's 5.4 for males, or even Middle Africa, around 4.5. Big difference.
Huge difference.
And there's that gender disparity, too. Men have a rate 2.4 times higher than women.
Nearly 2.5 times more likely. So these massive disparities, plus that initial paradox overall decline but cardia increase, that leads us right into the evidence, doesn't it? Trying to explain it all.
Indeed. And to understand these things, we really rely on the work of, major global bodies that assess cancer research.
Like IRC.
Exactly. The International Agency for Research on Cancer, IRC, and also the World Cancer Research Fund International, WCRF, working with the American Institute for Cancer Research, AICR. They constantly evaluate the evidence for risk factors.
And update it.
Right. And Table 1 in your source material lays this out beautifully. It's a great overview.
Okay, Table 1. Risk factors of gastric cancer according to evidence levels. This seems critical. So when these groups say sufficient evidence versus limited evidence for a carcinogen, what does that actually mean for us? Like, how solid is the link?
That's a really important distinction. When IRC says sufficient evidence in humans, it basically means there's a strong, consistent body of evidence from human studies. It clearly, definitively links that agent to causing cancer. It's, a very robust conclusion.
So pretty much case closed on that link.
You could say that. Now, limited evidence means there is some evidence suggesting a link, but maybe it's not as strong or consistent across all studies yet.
So suggestive, but needs more research.
Precisely. It points to a possible association, but we need more data to be completely sure.
Got it. Okay, so what does Table 1 tell us specifically for gastric cancer? What's in that sufficient evidence category according to IRC?
All right, so under IRC's sufficient evidence, we find Helicobacter pylori. That's a big one we'll definitely talk more about.
Okay.
Also, certain occupational exposures like manufacturing art glass, glass containers, rubber products, all forms of asbestos are in there.
Right.
Tobacco smoking, Epstein-Barr virus, X and gamma radiation, and inorganic lead compounds, too. These are all definitively linked.
No real scientific doubt there. And the limited evidence list.
For IRR's limited evidence, it includes ingested nitrate or nitrite, but specifically under conditions where they form nitrosamines in the body. Also, opium consumption, traditional Asian pickled vegetables, Chinese-style salted fish, and processed meat consumption.
Interesting. So evidence is building, but not quite at that sufficient level yet for those.
Exactly. And Table 1 also shows the WCR AICR classifications. They mostly align, but sometimes add a bit more nuance.
Okay, what do they consider established or strong?
Their established or strong evidence list includes smoking, H. pylori infection, alcoholic drinks, and foods preserved by salting. Pretty similar there.
Right.
But under their limited suggestive evidence, they list grilled or barbecued meat and fish, industrial chemical exposure, low fruit intake, and body fatness.
Ah, body fatness.
Yes. And crucially, they specify body fatness, particularly for cardiac-gastric cancer.
Okay, that type-specific link again?
Exactly. And interestingly, they also list citrus fruit as potentially decreasing cardio risk, and processed meat is mentioned specifically for non-cardiac cancer risk in this category.
Wow, okay. So that table really gives us a great high-level map of the risk factors and the strength of the evidence, and it starts to show those key differences between the cancer types.
It does. It sets the stage.
So what does this all mean for us as individuals? How do we translate these broad classifications into specific risks?
That's where Table 2 becomes incredibly helpful. It gives us actual numbers. The title is Associated Risk Factors with Gastric Cancer and RRs of the recent meta-analysis or pooled analysis. Right, relative risk, RR. And also gives a 95% confidence interval, or CI.
Okay, break that down quickly. What's RR mean?
Sure. An RR of 1.0 means no change in risk, it's baseline. An RR of 2.0 means your risk is doubled. An RR of 0.5 means your risk is halved.
Simple enough. And the confidence interval.
The CI gives us a range. It tells us where the true risk likely falls, based on the study data. A narrower range means a more precise estimate.
Got it. So Table 2 gives us these RRs for overall risk and, importantly, for cardia and non-cardia types separately.
Exactly.
Yeah.
We can see how the risk changes depending on the specific factor and the specific type of gastric cancer.
Excellent. Let's walk through some key factors from Table 2 then. First up, family history. How big a factor is genetics here?
Family history is definitely significant. The source suggests it can increase your risk by about 2 to 3 times compared to someone with no family history.
Okay.
Now, most cases are sporadic, meaning they just happen, no clear inherited link. But about 10% do show this familial clustering.
And the RRs from Table 2?
Table 2 shows an overall RR of 1.84, so nearly double the risk.
Right.
What's interesting is the breakdown. For non-cardiac cancer, the RR is 1.82. For cardiac cancer, it's lower at 1.38.
So the family link seems a bit stronger for the non-cardia type.
It appears so, based on this data. The source also adds a point about Asian regions. Even though family history is more common there, the high background rates mean environmental factors might still play a really big role, even in those familial cases.
Fascinating. Okay, now for what you called the big one. Helicobacter pylori, H. pylori, classified as a group 1 carcinogen. What does the data show about its role, especially with these different cancer types?
Right. This is arguably the most significant single risk factor. It's a bacterium, gram-negative, that can mess with gastric cells directly or cause chronic inflammation.
Okay.
Overall, H. pylori infection boosts gastric cancer risk by almost 3 times. And if it's a long-term infection, that risk can jump to nearly 6 times higher.
Wow. And it's common, right?
Very. Globally, around 44% of people are infected. Higher rates in Asia.
So let's get into the Table 2 numbers here, because you said this is key to that paradox we started with.
Absolutely critical.
Yeah.
Okay, Table 2 shows an overall RR for H. pylori infection of 2.56. Significant risk.
Right.
Now, for non-cardiac gastric cancer, the RR is a hefty 2.81. And that holds true pretty much regardless of the region.
Okay, so strong link to non-cardia everywhere.
Yes. And this helps explain why non-cardia rates are falling globally, because H. pylori infection rates are also falling thanks to better sanitation and treatment.
Makes sense. But what about cardiac cancer?
This is where it gets really interesting. For cardiac gastric cancer, the overall global RR is much lower, just 1.08. And importantly, that's not statistically significant. It means globally, there isn't strong evidence linking H. pylori to increased cardio risk overall.
Huh, okay. But does it vary by region?
Massively.
Yeah.
Look at East Asia. There, H. pylori is linked to a significantly increased risk for cardiac cancer. RR is 2.86. And for non-cardia in East Asia, it's even higher, 4.36.
So in East Asia, it increases risk for both types, especially non-cardia.
Correct. But now look at Western regions. The association with cardiac cancer is not statistically significant. In fact, the RR is 0.80.
Wait, 0.80, that's less than 1.0. That's just, it might even lower the risk.
Potentially, yes. The source explains that H. pylori infection, particularly in the cardia area, can actually reduce stomach acid secretion. Less acid might mean less inflammation in that specific area for Western populations, possibly lowering the cardiac cancer risk.
Wow. Okay, so H. pylori declining could explain falling non-cardia rates globally, but might contribute to rising cardia rates in the West by removing that potentially protective effect.
That's a major part of the hypothesis, yes. It's a key piece of the puzzle explaining why cardia rates are increasing, especially in Western countries, as H. pylori becomes less common.
That is fascinatingly complex.
It really is. And just quickly, while H. pylori is the main player, Epstein-Barr virus is another infection linked. Found in about 10% of gastric cancers, also increases risk, though maybe less understood.
Okay. That regional difference with H. pylori is a huge takeaway. Let's move to another well-known factor, smoking. How bad is it for gastric cancer specifically?
Smoking is definitely a significant established risk factor. The source estimates it contributes to about 11% of global gastric cancer cases.
Still a big chunk.
And maybe even higher in Europe, around 17%. Smokers generally have a 1.5 to 2.5 times increased risk compared to non-smokers.
And the RR from Table 2?
Overall RR for smoking is 1.61, so about a 60% increased risk.
Okay. And does it affect both types?
Yes. Importantly, smoking significantly increases the risk for both cardia with an RR of 1.56 and non-cardia with an RR of 1.43.
So bad news for both types if you smoke.
Definitely. And as you'd expect, there's a dose-response relationship. The more you smoke, the longer you smoke, the higher the risk.
Right. Okay, what about alcohol?
Alcohol consumption, the main issue is acetaldehyde. It's a toxic byproduct when your body metabolizes ethanol, and it can damage DNA. The source notes that even a daily intake of just 10 grams of alcohol that's less than one standard drink is associated with a slight 1.02-fold increased risk. But heavy drinking, defined here as more than 3 drinks per day, significantly bumps up that risk.
Okay, what does Table 2 show for alcohol?
It gives a couple of comparisons. Comparing never versus ever drinking, the overall RR is 1.2 and the cardia RR is 1.18. But interestingly, for non-cardia, the RR is 0.93, which isn't statistically significant.
So just ever drinking doesn't show a strong link to non-cardia?
Based on this meta-analysis, not a significant one. But if you look specifically at never versus heavy drinking, the risks jump significantly for both types.
Ah, okay.
The cardia RR for heavy drinking is 1.61, and the non-cardia RR is 1.28. Both are significantly elevated.
So heavy drinking is clearly a risk for both cardia and non-cardia, even if lower levels might primarily impact cardia risk.
That's what this data suggests, yes.
Another modifiable risk factor then. Now let's talk diet. Everyone worries about this, specifically high salt intake and processed meats.
Dietary factors are crucial, absolutely. Carcinogenic substances in food can directly interact with stomach cells. The sources really highlight traditional Asian salted foods, pickled vegetables, salted fish as having strong evidence linking them to higher risk.
Right, and salt itself.
Excessive salt intake can damage the stomach lining, cause inflammation, potentially atrophy, and it might even help H. pylori colonize better.
Okay. What are the RRs for high salt?
Looking at Table 2 for high salt intake, overall RR is 1.24, cardia RR is 1.25, and non-cardia RR is 1.46.
So a noticeably stronger link with non-cardia for high salt intake in general.
It seems so from this analysis, yes. Though some specific salted foods like pickled vegetables showed risk increases too.
Okay. And processed meats, like bacon, sausage.
Yeah, those are a concern mainly because they often contain high levels of salt, but also nitrites and nitrates. These can form N-nitrosamines in the stomach, which are known carcinogens.
Right, and the risk level.
Table 2 gives an overall RR of 1.23 for processed meat consumption. For cardia, it's 1.34, and for non-cardia, it's 1.24.
So a risk factor for both, maybe slightly more pronounced for cardia in this analysis.
That's what these particular numbers suggest, yes.
And briefly, what about fruits and vegetables? I always thought they were protective.
Well, they are generally very healthy, packed with antioxidants. And some older analyses did suggest they reduce stomach cancer risk. But it's worth noting, the most recent WCRF-AICR report actually downgraded the evidence level for fruits and vegetables specifically for preventing gastric cancer down to limited.
Oh, really? Why?
Basically, the large, well-designed cohort studies haven't consistently shown that strong protective association specifically for gastric cancer. It doesn't mean you shouldn't eat them. They're vital for overall health.
Right.
It just means the direct evidence for them specifically preventing this cancer isn't as rock solid as maybe once thought.
Good clarification. Okay, next risk factor, obesity.
Right. Obesity is understood as a state of low-grade chronic inflammation, and that inflammatory environment can promote cancer development.
How so?
Things like tumor necrosis, factor alpha, interleukin-6, these inflammatory markers are increased, and they can encourage cells to proliferate and help cancer cells grow.
Okay. And the link to gastric cancer specifically, what does Table 2 say?
Table 2 shows obesity increases overall gastric cancer risk by about 20%. The overall RR is 1.22.
Okay.
But again, we see a difference between the types. The link is notably stronger for cardiogastric cancer. The RR there is 1.32, about a third higher risk.
In non-cardia?
For non-cardia, it's a smaller increase, an RR of 1.18. This stronger link between obesity and cardiac cancer is similar to what we see with esophageal cancer nearby.
Interesting pattern. Okay, finally, let's touch on chemical and radiation exposure.
Sure. The source mentions occupational exposures, things like dust, high-temp particles, metals like hexavalent chromium. These are often seen in industries like rubber manufacturing or metal processing and are associated more with non-cardiac cancer.
Are there specific risk numbers?
The text gives a few examples. Asbestos exposure showed a standardized mortality ratio of 1.15. Talc exposure, a 1.21-fold increased risk. Silica exposure, a 1.25-fold increased risk for workers in those fields.
Okay, and radiation?
Radiation like X-rays and gamma rays is also a Group 1 carcinogen for gastric cancer, according to IRC.
Where's the evidence from?
Studies on atomic bomb survivors, for instance, and also studies on pediatric cancer patients who received radiation therapy. They show a clear increased risk of gastric cancer later in life, and the risk goes up with higher radiation doses.
Right, makes sense.
One example cited was pediatric cancer patients having a 4.6 times higher standardized incidence ratio for gastrointestinal cancer compared to the general population after radiation exposure.
Wow, significant risk there too. Okay, we have gone deep into these risk factors, really breaking down those tables and getting the nuances between cardia and non-cardia types. Now, the empowering part. What can we actually do? What's the advice for primary prevention based on all this?
Right. Primary prevention is all about trying to eliminate or avoid those risk factors in the first place to stop the cancer from ever starting.
So what are the key strategies?
Well, based on the evidence we've discussed, one of the most impactful things is H. pylori eradication.
Treating the infection if you have it?
Exactly.
Yeah.
Recent large studies, meta-analyses, show that people who get treated for H. pylori can cut their gastric cancer risk by around 50%.
50% reduction. That's huge.
It is. Table 2 actually shows an RR of 0.54 for H. pylori eradication. That means roughly half the risk compared to leaving it untreated. And this benefit was seen even in people who didn't have symptoms but were found to be infected.
Really important point. What else?
Quitting smoking is obviously a major one. We saw it increases risk for both types. Global anti-smoking efforts have made a difference here.
Absolutely. Alcohol.
Reducing alcohol consumption. The recommendations vary a bit. Some say limit to 1-2 drinks a day. The American Cancer Society ideally suggests none. But certainly reducing heavy drinking is key.
Okay.
Maintaining a healthy weight that directly tackles the obesity risk factor, especially relevant for cardiac cancer.
Right.
And adopting a balanced diet with a focus on low salt intake. The WHO recommends keeping salt under 5 grams a day for adults. That helps prevent various diseases, including potentially gastric cancer.
So what does this all mean for you, our listener? We've seen gastric cancer epidemiology is, well, it's incredibly complex. It varies hugely by region, by cancer type, even over time.
It really does.
But focusing on these modifiable risk factors, H. pylori, smoking, heavy drinking, weight, salt intake, that seems to be our best defense. And digging into these tables, it really helped illustrate those connections, didn't it?
Absolutely. Understanding, for instance, that H. pylori's impact on cardia risk is so different depending on where you live compared to his more universal impact on non-cardia risk.
Yeah.
That's a level of detail that really matters.
It moves beyond just saying H. pylori is bad.
Exactly. It highlights that critical distinction.
Yeah.
We have this overall decrease in non-cardia cancer, which is great. But alongside it, this worrying rise in cardiac cancer.
Yeah.
It shows how these risk factors play out differently.
So reflecting on all this detailed information we've unpacked.
Yeah, this deep dive into your sources, it really brought out how interconnected and dynamic it all is.
It leaves us with a final thought, doesn't it?
I think so. Given how much our understanding is still evolving, especially with these regional variations and that rising cardia trend, you have to wonder what new insights will future research uncover, particularly about why cardiac cancer is increasing in certain areas. And maybe more importantly, how can we make sure that new knowledge gets applied effectively everywhere to really improve prevention globally?
A really powerful question to ponder. Thank you for joining us on this deep dive. We hope this exploration gives you valuable knowledge for your own health discussions and decisions.